Sine 2 theta equals 2 sine theta cos theta. So again, for instance, sine of 74 degrees, like I said before, is the same as 2 times sine of 37 times cosine of 37. Those two things are equal. So here are just some questions to try and ask you which, and they're multiple choice. They're nice multiple choice that have like 8 different answers or 12 different answers, or I don't know what I was thinking, but I wanted to put all the possibilities in so that you couldn't figure it out just by eliminating possibilities in the answers. What is this equal to? 2 sine 30 cos 30. You have to think about that identity, and you have to recognize, well, that looks a lot like that identity for which one? Yeah, for sine of 2 theta, right? You have 2 times sine of an angle times cosine of an angle. That's what that identity says. It says 2 times sine of an angle, cos of an angle is the same as sine of twice that angle. So what's this the same as? Sine of 60. Is there a 2 in front? No, this 2 is just part of it, right? People get uncomfortable because they think, well, the 2 disappears. Am I supposed to factor out the 2? There's nothing about factoring here or anything, right? You're just trying to look for what it's equivalent to. It's the same as sine of 60. Same thing with these other ones here. There's an expression and you think about what it's equal to. Expressions here where it doesn't look exactly right to start with because there's an 8. Well, you're pretty good at knowing that if you have 8 times something, you could think about it as 4 times 2 times something, and then you can figure it out. Or the same thing over here, right? Just write it, write it so that there is a 2 in front of it. As far as the proofs, I'm purposely not doing all these questions for you here. As far as the proofs here, the proofs are not much different than what you've had before, except you have a couple new identities that you're going to use. And you have to look carefully and see that sometimes now it's going to be sine of twice an angle. That actually should be the easiest thing to know what to do, because there's only one thing you can do with that sine of 2 theta. What can you do with sine of 2 theta? What can you change it to? Yeah, 2 sine theta cos theta. So you can replace sine 2 theta with that. I better leave myself enough room here. You can replace sine of 2 theta with that. And then the other stuff, what can you do with the other stuff here? This side over here is pretty easy. I'm going to just leave this alone and know that I'm trying to make it look like sine of 2 theta or sine of theta in the end here. So I'm going to work on the left side here. This secant theta, I could change that to, what could I change that to? Yeah, 1 over cos theta. And then minus sine theta, I'm going to leave that all by itself. So secant theta becomes that. And then minus sine theta, subtracting sine theta, just leave it the same, right? That's a subtraction, don't get mixed up. It's a subtraction, right? You're subtracting 2 terms. You have this stuff minus this stuff. You're not multiplying all of that. This I could simplify a little bit here. And in fact, I think I'm going to write it as 2 sine theta cos theta. Instead of times 1 over cos, I'm going to write it as divided by cos. Does that make sense to you? Times 1 over cos, just write it as divided by cos. You don't have to write that step. That's, you could probably see right away that you can do what to simplify this thing. If you have times cos divided by cos, yeah, these are going to divide to 1. They cancel out, right? So what do you have there? 2 sine theta minus sine theta. Some people think, 2 sine theta minus sine theta is 2. It's not 2, right? It isn't that you're taking away sine theta. When you first learned about, working with algebraic expressions, probably in grade 8 or 9, you said 2x. If I have 2x and I take away an x, all I have is a 2. It's not true, right? 2x take away x, what is that? Yeah, 1x, right? Just an x. So if you have 2 sine theta and you take away sine theta, you have, here's a big hint here too, that you're trying to make it look like that, right? 2 sine theta, take away sine theta, you just have 1 sine theta, right? Sine theta is like it has a 1 in front of it, don't forget. So you're done there with that. The other proofs are just the same as what we've always done, except for there's double angles involved, right? There's a double angle involved there. There's a double angle involved there. It's harder when you have to work with cosine of 2 theta because you got some choices here. Some hints here that I tried to possibly point out over here. Right? There's only one choice on the bottom. There's a bunch of choices on the numerator. Another hint here is at some point you want to turn this into a single trig function over here. But you have this. Notice that anytime before that you had a thing with 2 terms in it, you could turn it into a single term by using one of those sine squared plus cos squared equals 1. This had 2 terms turn into 1 term. Well, you have some more choices here for how to turn 2 terms into 1 term because you have identities like 2 cos squared theta minus 1 equals cos 2 theta. This is 2 terms. This is 1 term. It's a way of turning this thing from 2 terms into 1 term. You have some to choose from here. The bottom you have no choice. You're going to put what sine 2 theta is equal to. But the top, you should pick something that's going to allow you to cancel out this 1. I don't want to do it for you because I want you to think about it, but if you were to choose properly, then you'd have 1 and you'd have a negative 1. They'd all cancel out and it would work out to something nice. You should work through these and think about it and check what you're doing. There's hints at the side. There's hints at the bottom. Then you can move on to these check your understanding. In that binder at the front, there's a possible solution for each of these. There's not the answer. There's lots of different ways to do these things. There isn't only one possible answer. It's probably a common way to do it, or even if it's not. If you've done these proofs another way, fine, as long as you haven't made any mistakes. This is a challenging one if you want to try and get it to work. I want to give you the rest of the time to work on this. Okay? There's a lot to do. Start from the beginning. Don't spend forever on these questions at the beginning, but you really should think about it. The questions at the beginning. Why do they call them double angle identities? Don't take more than 30 seconds to write something there for yourself. How are they different? Well, I don't know, order of operations, something inside the brackets as opposed to outside. Think about how you could verify it. Definitely pay attention to this and make up an example that shows the difference here between these. Grade 12s confuse this very much, either because of sloppy handwriting, small 2's, big 2's, and they get this mixed up because they think somehow you're factoring things. Think about that. Okay, then get going on finishing the rest of it. Can we try and aim to finish this today, I hope, so we can move on to 5-9 next time?